This video is to go over homework packet 7B, lesson 7.07, problem number 10. Three vertices of a square are -1, 5, 5, 3, and 3, -5. -3. So let's plot that first. -1, 5, which is this one, 5, 3, and 3, -3. Okay? Am I doing right? 5, 3, -1, 5. Okay, so those are the three vertices of the of a square. So let's see. Part A says find the center of a square. So do you see a square here? You need one more vertex. So that's part B. So find the center of square. Right? Let's think about the square, right? Square. How do you find the center of the square? You draw two diagonals like this, and the intersection is the center, right? So find that, and then find the fourth vertex. So where would you plot the points so that it looks like a square? Right now, it's not really. It doesn't really look like a square. So where would you plot the points so that we can see the square? So that should be coordinates, right? Okay, moving on to 7.8, problem number 5. That is on page 3 in that packet. It says suppose you have points A, B, C, D. So A is 4, 1. So 4, 1. B is 8, -2. C is 7, 1. D is 3, 4. This is A, B, C, D. Show that the diagonals of quadrilateral ABCD bisect each other. So, quadrilateral ABCD. Show that this bisect each other. Right? So you got the diagonal BD, and you've got the diagonal AC. So it says that this green line segment is bisecting B to D. Also, this blue line segment is bisecting AC. That means splitting the green segment into two. But how do we know? One way to know that is to find the vertex of this. Find the coordinate of this point. Right? And then think about the coordinates of A and C and B and D to see why, how this shows that this diagonals of quadrilateral bisect each other. So that's part A. And part B says, what does this tell you about what kind of quadrilateral ABCD is? Do you remember there are special kinds of quadrilateral? Maybe that could be, what's the quadrilateral? That could be square, rectangle, kite, parallelogram, trapezoid, isosceles trapezoid, right trapezoid, and so on and so forth. And which one is it and why, right? So knowing that diagonals bisect each other, we can tell what kind of quadrilateral this is, but which one? So that's 7A, problem number 5. Moving on to lesson 7.09, problem number 8, which is on page 4. It says find the area of the triangle with the given vertices. So A is 1, 1, B is 4, 5, C is 13, -4. Okay. All right, so we have the triangle. So what do we know? What do we need to know to find the area of the triangle? That's right. It's half of base times height. So you can claim any side as a base. In this time, I'm gonna claim that AC is my base. And I'm going to claim that perpendicular line here is the height. Okay? So what we need to find out is to find out what the length of BC is. Okay? Also, we need to find out the heights of B2, these unknown points. So first we need to, using distance formula or using Pythagorean theorem. Do you see right triangle here? Right? So from here to here is 1, 2, 3, 4, 5. From here to here is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So using Pythagorean theorem, you can find what B is pretty quickly. But how do we find these unknown points, right? So that is the biggest challenge that in this problem. What we learned in, what page is this? So that's the distance formula, which is 7.01. So that's 7.09. So in this, if you look at theorem 7.6, two non-vertical lines are perpendicular if and only if the product of the slope is -1. So looking at this one, looking at the blue line, what is the slope of it, right? The slope of a C is, from here to here, is rise over run. So you go down 5, 12 over, so -5 over 12. And then if you look at slope of B2, let's call this D, the intersection point B. BD is something, right? So we don't know, that's unknown. So if you multiply -5 to 12, -5/12 to x, that should be -1. What is x? So find x first, right? And that's going to get you to somewhere, right? So finding the slope, and that's going to, oops, I should write that, right? Because that we don't know that. That's going to help you to identify D, because you can say that the line DB will be y equals something, this one, x plus some number b, right? Remember mx plus b, right? And if you I don't want to give too much hints, but if you find out, if you solve, so set that up, and then find the equation of this line, which is very easy to find because you already know what this is, right? So line B is y equals mx plus b. The m is -5/12 x plus some b. And we also know that a is 1, -1, so we can, 1, 1. So we can plot that in to find what the b is, right? So y equals 1, which equals -5/12 times 1 plus b, right? So that's 1 equals -5/12 plus b. Adding 5/12 to both sides to cancel out. That's going to give you b equals 1 plus 5/12, but 1 is 12/12. So it's 17/12. So the equation of this one is y equals -5/12 x plus 17/12. That's the equation of this. So doing the same thing, find the equation of this line segment BD, right? You know how to find m by doing this, and then plot the point B, which is 4, 5, right? And then find out the equation. This is And then set the system over equation to find out what the x and y is. That's going to give you the point P. Once you find that, use the distance formula to find the lengths from D to B. Now finally our goal is to find the area of this triangle. So take that height, multiply by the base, and then divided by 2 will give you the answer. It's a long process, but it gives you a good practice and review for many things. Okay, let's move on to lesson 7.10. Problem number 7. So we kind of have to use something different here. Well, we can actually look at this one. Right. Let's zoom in. So it says find the coordinates of each vertex. So what's the vertex of this origin? This origin right here is x is 0, right? Y is 0, just like normal coordinate plane, but this is a 3D version of it, so we have z-axis, which is 0. How about A here, right? What's the vertex of it? What's the coordinate? What's the x coordinate? X coordinate is 0. What's the y coordinate? You're not going to the direction of y at all, so it's also 0. But on z, you go up 1, 2, 3, so it should be 3. Okay, how about B here? I'm not going to do everything, but I'm just going to do it so that you get some idea, right? B, do you go x-axis at all? Do you move on x-axis at all? No, so it's 0. How about how do you get from here to B? Well, you have to go to y-axis 1, 2, 3 spaces, and then after that you go up 1, 2, 3 spaces. So the coordinate is 0, 3, 3. So do that for the rest, C, B, D, E, F. So that's what you do for this problem. And that's the end of this pack